Alright guys, so today we're going to be talking about the math behind Newton's second law, which is force equals mass times acceleration.
Yes.
So when we're talking about mass, we need to remember that this is different than weight. Mass is how much stuff is there. So we can kind of transfer them, we can calculate between mass and weight easily because everything on Earth has a constant acceleration. Everything is being pulled down by gravity at the same rate.
And what is that rate again?
That's negative 9.8.
Negative 9.8.
Okay, but a mass is literally how much stuff is there. We can measure it on a scale, but okay. And then the other part of that is acceleration, which is how fast something's being pulled. Anything that changes speed or direction is accelerating. So that's like whenever you give your car some gas, or whenever you turn, you're accelerating.
So when I speed up, I slow down. So if I'm driving at the same speed, but I'm turning in a circle,
You are accelerating.
I'm still accelerating.
Yes.
Okay.
All right. It can also mean it's slowing down. Also, if it's a change in
Right.
speed.
Okay.
Okay. So
Get that off. Okay.
we also need to know that weight is the mass times the acceleration due to gravity. So that's kind of very similar to that formula.
It is. So if force is mass times acceleration, you're telling me weight is force times acceleration. So does that mean that weight is a force?
Weight is a force.
Okay.
Okay.
That's good to know.
So that's the difference between mass and weight, is that mass is how much stuff is there, and weight is the force that stuff is being pulled down.
Okay. So since my mass stays the same, regardless of where I am, depending upon the acceleration of gravity of where I'm at. So on Earth, it's always the same, but if I were to go to the moon, that is why my weight would be different.
Right.
Because the acceleration is different.
Right.
Okay.
I'm still made up of the same amount of stuff, so I still have the same mass if I go visit the moon, but I weigh less because it's a smaller planet, so it's got less gravity on the moon.
Okay.
So let's take a look at this practice problem. Yeah.
No, this one. How much would a book weigh on Earth? Okay, how much would a 2-kilogram book weigh on Earth?
Okay.
All right, so we said weight is a force. So we can just say weight would be equal to the mass of the book times acceleration.
Right.
And we know acceleration on Earth is
negative 9.8.
negative 9.8. So we said the mass of the book was 2 kilograms. And acceleration is negative 9.8 meters per second squared. Okay. So all we have to do here is multiply. And when we do that, we get negative 19.6. This, I guess, technically is 9.81. So 19.62 kilogram meters per second squared. I multiplied, so I'm just kind of smushing these units together. Do we have a unit that kind of abbreviates the kilogram meter per second squared?
Yes.
And what is that called?
It's a Newton.
A Newton, and whose law is this?
Newton's laws! Oh my goodness.
Look
Okay.
at that.
So wait, but why is that a negative number? When I say something weighs 19 newtons, I don't say negative 19.
This is true. The reason it's negative is because we have that negative in the acceleration,
Right.
which denotes or tells us that the force is pulling in what direction?
Down.
Down.
Oh, so the weight is being pulled down.
Down.
So the negative tells us our
The
direction.
negative tells us our direction.
Okay.
That's all.
All right.
Okay, so negative 19.62 newtons is the weight of this book on Earth.
Okay. What do you say we find out what this book weighs on the moon?
Okay, let's do that.
So
Has mass changed?
no, mass
No.
is still the same.
Mass has not changed. Weight is equal to mass times acceleration. Our mass, we said, is 2 kilograms. But what's the acceleration due to gravity on the moon?
Well,
1.62 meters per second
Oh,
squared.
1.62 meters per second squared.
Okay, so less than that of what it is on Earth, which is why we weigh less on the moon. Negative, because it's pointing downward, pulling us down. So now 2 times 1.62 is negative 3.24, and it's the kilogram meter per second squared, and we're just going to put a big fat N for Newton.
Okay.
Because force is measured in newtons. Not the same as pounds, but you
Right.
can convert from newtons to pounds.
Right.
Okay. All right, cool.
So now let's take a look at some of these practice problems.
Cool.
Let's take a look at this guided practice problem here.
Okay.
We have Roberto and Laura are studying across from each other at a wide table. Laura slides a 2.2 kilogram book towards Roberto. If the net external force acting on the book is 2.6 newtons to the right, then what is the book's acceleration?
All right, so we're solving for A here. Okay, so we know our formula is F equals M times A. But if we're solving for A, we have to rearrange this. So we would
Divide both
by-
sides by mass. Masses would cancel out on that side.
So A is equal to F over M. All right, so our F is 2.6.
0.2. Oh, so 2.6.
And our
newtons.
mass is
2.2.
And so when we do the math, 2.6 divided by 2.2, we get 1.18, which I'm going to round to 1.2. Now, what are our units going to be?
Newtons? No.
Well, all right, guys. Remember, the Newton is the kilogram meter per second squared. And
Oh.
we're able to cancel
Pull
out
out the
those kilograms.
kilograms.
So we're
And-
left with meters per second squared. And does that look familiar for
Yes.
acceleration and unit?
Yes.
It does.
Okay.
Okay. Okay, so you said in the problem that we have slid the book to the right. So that's a direction.
Right.
And we have a magnitude for force. So would that mean that force is a vector quantity? Oh, look at that. Magnitude and direction.
Yes.
Yeah. Okay.
All right.
All right.
So, real quick, let's show you guys another quick way to do this. Sometimes we'll get it's easier for me sometimes to just plug in the numbers
Okay.
instead of, so we would have force equals mass times acceleration.
Okay.
All right. And we are solving for
Acceleration.
acceleration. So I'm going to plug in my force, which is 2.6,
Okay.
is equal to mass, which is 2.2,
Okay. Times our
acceleration.
acceleration.
So this is the way I like, and we're going to divide both sides by our 2.2, and then we'd still get the same answer, which is going to be our acceleration is equal to 1.18 meters per second squared. Okay? Now, let's take a look at this next practice problem. A 2.0 kilogram otter starts from rest at the top of a muddy incline at 8 meters long and slides down to the bottom in 5 seconds. What external force acts on the otter along the incline?
All right. Oh, it starts from rest. Oh my gosh,
Starts
this is
from
giving us
rest.
all kinds of crazy stuff.
Uh-huh.
Sorry, I went a little out of order here.
It's okay, but we're using the formula force equals mass times acceleration, but I don't have acceleration.
No, we have
What?
mass, we have distance, we have initial velocity, we have time.
Oh, we can go back to our kinematic equations.
Yes, we can. All right, so let's look. We know force is equal to m times a.
Uh-huh.
We're solving for force. We have mass.
but we don't have
We don't
acceleration.
have a. Do we have what we need to solve for acceleration?
Yes, we do.
We do. We have distance, we have initial velocity, and we have time. So which one
Okay.
of those big three kinematic equations are we going to use? Ding, 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 ding. Oh, the third one.
The third one,
Yeah.
yes.
Good job, guys. We know that distance is equal to initial velocity times time plus 1/2 AT squared. All right. So
now, we've got all that math worked out. That should be familiar to you here.
okay. We've plugged in our numbers. We know that initial velocity is 0, so that part of the equation goes away. Our time is 0.5 seconds. Our distance was 0.85 plus 1/2 AT squared. We're solving for A. Okay, so in this example, we've plugged in the numbers for you first. 0.85 is equal to 1/2 AT squared. We squared that T, so 0.5 squared is 0.25. 1/2 of 0.25 is 0.125. So we divide both sides by 0.125, so that we're left with A is equal to 0.8 divided by 0.125. When you do the math, you get 6.8. And then we're able to go ahead and plug that into F equals M times A. So M is 2, our A is 6.8. 2 times 6.8 gives us 14 newtons. So we are combining F equals MA with those big three kinematic equations. Guys, they don't go away. We're going to keep seeing them.
Okay.